0 interest, then I know that 500 times 6 is $3,000. She would need to have $3,000 ready or carry it in cash on her trip. But if you can get interest or free money from the bank based on just keeping your money there, then you may as well do that. Now, we know that this is an annuity question. How do I know that? Because it says withdrawing money at the end of each month for 6 months. This is a regular withdrawal, and it's at a regular interval. So, regular payment of $500, and we have regular interval, and the interval is monthly. I'm going to draw a diagram to illustrate this. We have our first month. Ioanna is going to withdraw $500. Month 2, Ioanna is going to withdraw $500. Month 3, $500. Month 4, $500. Month 5, $500. And month 6, also $500. I'm going to put this as a timeline. Now, she has to be putting in enough money so that she can withdraw that amount at the end of each month. And we note that it's the end of each month because that would mean it has the entire month to collect interest. If we were to look at just one of these payments, then we would be looking at simple or compound interest again, meaning the equation that I use would be A is equal to P times 1 plus I to the power n. I'm given the amount and I need to find the principal. So I'm going to reverse the equation. I could have P is equal to A over 1 plus I to the n. So this is kind of similar in finding the individual principal. So at the end of the first month, I need to withdraw $500, but whatever the initial sum is had earned enough interest for it to reach $500. So let's rewrite it as a present value, 500 divided by, and we need to find our I for this case. I is 0.06 compounded monthly. Divided by 12, that gives us 0.0, do it on the calculator, 0.06 divided by 12, 0.005. So we have 1.005 to the power 1 to find the original principal of what would give us the final amount of 500. The second month, I'm going to do that again, except this $500 that I'm taking out has sat in the account for 2 months now. So I have 1.005 to the power of 2. Month 3, this sum of money has sat in the bank account for 3 months now, and so on and so forth. So I'm just going to quickly write down the other ones. So this is all of the principles of what had to be input to get $500 at the end of each month. So for me to get the present value, I would add up all of these. Present value, add up the principals. So the first month plus second plus third plus fourth plus fifth plus sixth. I'm going to go through this in my calculator and type each one in. 500 divided by 1.005 plus 500 divided by 1.005 to the power of 2 plus 500 divided by 1.005 to the power of 3 plus 500 divided by 1.005 to the 4 plus 500 divided by 1.005 to the 5. And finally, our last one, 500 divided by 1.005 to the power of 6. Our final answer, 2,948 and 19 cents. So all of that becomes 2,948 and 19 cents. This is the amount of money that Ioanna has to put in the bank account today so that she is going to be able to take out $500 every month for the next 6 months. So the next question, how much interest did she earn? Well, let's look at it this way. We've taken, initially she would have had to put in $3,000 for her to get 500 at the end of the month. Instead, she only had to put in 2,948 and she got out $3,000. Let's take that and subtract it. So in total, she put in 51.81. Not a significant amount, but this is like free money. If somebody says, I'm going to give you a free $51, I would take it. So investing it this way in an account that gives interest is always worth it.